Introduction to IFC Standards. Before diving into the exciting capabilities of usBIM.refactor, let's clarify a few key terms about the IFC format, specifically what IFC 4.3 represents. The Industry Foundation Classes, IFC, is an open, non-proprietary format designed to encapsulate the geometric and alphanumeric details of buildings, prefabricated components, and electrical systems. This standard promotes seamless data exchange among construction professionals throughout the entire project lifecycle. Whether you're a designer, supplier, or contractor, IFC acts as a common language, enabling diverse software users to collaborate effectively. Since its inception with version 1.0 in the year 2000, IFC has evolved significantly. Following the launch of IFC 2x3, Building Smart set out to develop the next iteration, known as ifcCores, with the latest refinement being IFC 4.3. Key innovations in IFC 4.3. Let's summarize the innovations brought by IFC 4.3, categorized into three main areas. Alignment. This feature establishes a reference system to accurately position elements, particularly for linear constructions like roads, railways, and bridges. New spatial structure. This enhancement organizes entities within a BIM model hierarchically, offering a clear framework for project navigation. Introduction of new classes. These classes are essential for modeling specific entities, ensuring maximum interoperability across various BIM authoring tools. To address the complexities of mapping classes and spatial structures, ACCA software has developed usBIM.refactor. This application empowers BIM specialists to maintain older IFC format models or those that don't align with the new standard by refactoring them into a more compliant version. Understanding spatial organization. The spatial organization framework within the IFC standard is crucial for structuring and managing all physical and non-physical objects within an infrastructure model. With the release of version 4.3, this spatial structure has become more adaptable, particularly for linear infrastructure projects. In this new version, the project and site components are well defined, while additional classes enrich the IFC framework. These new classes differentiate individual assets, allowing for detailed decomposition into components like road and rail segments. The introduction of the user type helps in establishing a clear hierarchy, facilitating navigation, and enhancing processes such as clash detection and code compliance checks. Transforming your BIM models with usBIM.refactor. With usBIM.refactor, users can effortlessly create IFC 4.3 files from any BIM model. The tool enables the federation of multiple models into a single IFC file, transforming generic properties into a compliant IFC 4.3 format. This ensures your IFC model is not only comprehensive, but also up to date with the latest openBIM digitization standards for infrastructure, bridges, roads, and railways. This application simplifies the reorganization of your IFC model without needing the original software. You gain access to a robust database of all IFC 4.3 classes, enriching your new IFC model with elements tailored to your needs. Before we explore the functionalities of usBIM.refactor further, let's consider the addition of new IFC classes to better characterize model entities. While most objects are categorized as IFC building element proxies, usBIM.refactor allows for a deeper redefinition of both spatial structure and class mapping. With the innovations in 4.3, we can establish an ontological foundation and introduce verticalized classes specifically for infrastructures, enhancing the precise characterization of objects through predefined type attributes. Users can assign these attributes automatically or manually. The process is simple. Open and view your IFC BIM model online, regardless of type or size. Create a new spatial structure or load a previously saved one. Populate this structure with elements from existing objects. Export your newly arranged IFC model. Here's a use case of refactoring a viaduct. Let's look at a practical example involving a viaduct. Our objective is to evolve an IFC model from version 2.3 to 4.3. With usBIM.refactor, we can effectively manage the complexities of this transition. Starting with the IFC 2x3 model and associated generic classes, usBIM.refactor allows us to recreate a new spatial structure. We define a hierarchy from the project to the site, and then to the facility, systematically organizing the entire structure. By identifying interest classes, we can classify each appropriately, allowing for effective type enumeration. This process culminates in generating a new IFC file. Using filtering and selection criteria, we redistribute the new classes to the corresponding geometries. Once the reclassification is complete, we obtain a refined model in the 4.3 format. On one side, we have the original model. On the other, the newly processed version. By selecting various objects, we can observe how a generic building element proxy has transformed into specific classes like ifcCores and ifcPiles, showcasing the advancements made with the latest standard.